Yes, sir.
Okay, with respect to time delay, we have discussed already last class. We have discussed with respect to 8051. If you for 8051, Atmel 8051, we are going to take it as a clocks per machine cycles will be 12. With respect to that, we are going to take the frequency 11.0592. We are going to get time delay with respect to that 1.085 microseconds you are going to get. But in the case of advanced controllers, here we have two factors can affect the accuracy of the delay. First one is the crystal frequency. The duration of the clock period of the machine cycles is function of the crystal frequency. With respect to 8051, we have 12 cycles we have, but advances in both IC technology and CPU design. Recent years with respect to the one clock machine cycle, we are going to common feature. Okay, that is Dallas Semi has introduced only one clock machine cycle. Based on that, it will be vary with respect to the we have with the older version, that is your 8051, that will be 12 machine cycles. After that, Philips has introduced that 6 machine cycles. Based on this, we can vary. Okay, for example, the so far last we have discussed about these size of a delay in the following crystal frequency of 11.0592. This is for 8051. This will be this time how you are going to get 1.058 microsecond. This is divided by 12, and with respect to inverse of that, you will get this time. If they will mention that the processor will be Philips processor, for example, when they will give a problem, they will give a processor change. They will going to change the controller, that is Philips controller. If they will give P89C54X2 Philips, if they will give, you have to take a 6 machine cycles. If they will give DS5000 Dallas Semi, if they will ask, you have to use 4 clock cycles. Like that you have to change. Okay, 90% they will not ask, they will ask only for 8051. Okay, this is for extra knowledge. I'm going to discuss this. For this controllers, advanced current controllers, we have a machine clocks per machine cycles will be 6, 4, 1 respectively. Okay, next with respect to that, we'll have a find the period of the machine cycle for various versions of the 8051. That is external frequency will be same 11.0592 megahertz. If I'm going to take, I'm going to find for 89C, Atmel 89C51, and P89C54X2. Okay, and advanced version of controllers we are going to take. First one will be 11.0592. We have a 12 clock pulses. We have clock cycles we are going to take. You will get a 921.6 kilohertz. If I'm going to find the time for this, 1 by this, you are going to get a 1.085 microseconds or 1085 nanoseconds we are going to get. Okay, with respect to the second one, 11.0592 megahertz divided by 6, if I am going to take, you will get 1.843 megahertz you are going to get. With respect to that time, we are going to get a 0.5425 microseconds we are going to get. More than this we are going to get. You will get a 0.5425 microseconds. Again, this with respect to nanoseconds, leave. Then for the another processor, that is that processor DS5000, that will be 4 clock pulses. If I'm going to take the frequency, this is a frequency I'm going to get 2.7648 megahertz we are going to get. With respect to that time, I'm going to get 0.36 microseconds I'm going to get. 0.36 microseconds I'm going to get. Like that, it will be going to change the values with respect to the different controllers. Okay, please make a note of this and this slide and next slide. Then we'll go for next program. Or
Yes, sir.
make a note of this. Is it visible?
Yes,
Yes,
sir.
sir.
Or okay, take next. Okay, we'll use Notepad for this program. We'll discuss. Write a program to output the binary upcounting 00H2 0FFH sequence on port 1 and observe output on logic analyzer window. This is logic analyzer window. Okay, this is the question. This program we are going to discuss now. We'll 1 minute. Notepad is visible.
Yes, sir.
Okay, take the program now. org 00h sjump 30h org 30h move p1 comma hash 00h move a comma hash 00h move port 1 comma a call delay increment a yes jump b back across here we have a back. Then I am going to write the delay program here. Right side I am going to write the delay program. Delay move R4 comma as 00FH sorry 0FFH 0FFH then loop 3 move R5 comma hash 0 FFH loop 2 move R6 comma hash 04 H loop 1 no operation next DJNZ R6 comma loop 1 DJNZ R5 comma loop 2 DJNZ R4 comma loop 3 return end. Copied everyone program?
2 minutes, sir.
Okay, make it fast. I think delay program you are writing. Write down. 4.
Yes, sir.
Okay. See, first line of the program org 0000H, sjump 30H, org 30H. Why we have taken two different org 00H and org 30H? org is a assembler directive. We have 4 different types of assembler directives, that is org, equate, end and count. 4 different assembler directories we have. We have already discussed about this. org 000H, it means that it indicates that we are going to deal with a Keil software. It indicates that it is with respect to Keil software we are going to deal. That is why initially I am taking org 000H. I cannot start the program from 0001H. Why? Because it will not be allocated with respect to this program. This assembly language program in the Keil software, it will be starts from 30H. That is why after I am going to identify software org 000H, so that it means that I am going to deal this program in Keil software. That is the indication of your assembler directives, that it will be going to direct the software 000H. org 00H indicates the Keil software. The program will not start from 0001H. Why? Because the memory location is not allocated. That is why suddenly I am going to take a short jump, sjump 30H I am going to take. It means that I am going to jump to the 30H. Now I am going to initiate that org 30H. With respect to 2E address location will be present across the 30H of your org 30H address location. We have a address of memory location will be 2E, like that it will be going to assign. From this point we are going to write the program. From this point we are going to write the program. Keep it in mind why I am going to take two org 00H and org 30H. What is the difference? This is the main difference between org 00H and the org 30H. Now as usual I am going to take move P1, #00H. Can you tell me what is the meaning of P1, #00H?
Port 1 with 0 data, sir.
What is the meaning? What happens when I am going to load 1 to the port 1, 0 to the port 1? Port 1 ಗೆ 1 ಕೊಟ್ರೆ ಏನಾಗುತ್ತೆ? Port 1 ಗೆ 0 ಕೊಟ್ರೆ ಏನಾಗುತ್ತೆ? Can anyone please speak out?
Decrement, sir.
Huh?
Increment.
Sorry? Huh? See, port 1 is acting for both input as well as output. Okay. See here, to the program to write a program to output the binary up counting 00H to 0FFH sequence on port 1 and observe output on logic analyzer window. It means that we are going to use port 1. If I am going to feed port 1 as a 1, means if I am going to load FF to the port 1, it acts as a input port. Here I am going to load 00, it acts as a output port. It acts as a output port. That is the meaning of P1 is equal to 1, P1 is equal to 0. ನಾನು 100 ಸರಿ ಹೇಳ್ತೀನಿ, ನೀವು 100 ಸರಿ ಕೇಳಿಸ್ಕೊಂಡು ಆರಾಮಾಗಿ ಮರ್ತೋಗ್ತೀರಾ. Okay, Now, if I'm going to load 0, 0 to the port 1, so that I'm going to initiate that port 1 as a output port. This will be an output port I'm going to assign. Now, move a comma hash 00 h. Now, I'm going to clear the accumulator. Whatever the data in the accumulator, I am going to clear. Why? Because I need to put 0 to the port 1 initially. Why? Because my count is from 00 to FF. Initially, I need to put 0 to the accumulator. That is why I'm going to clear this accumulator, or I'm going to load 00 to the accumulator. Now, move port 1 comma A. Now, I have 0 in the accumulator. I have loaded with a port 1 is equal to 0, 0. Now, port 1 will be 0. Okay, what is the output? We need to show output in the logic analyzer. Logic analyzer means I need to represent like this. Again come like this. Again go like this. From 0 to 255 means this is 0 to FF means 0 to 255. It needs to go, and again it will be come back to 0. Again it will be going back. Like that I need to show in the logic analyzer. It means that now I have loaded 0. I have loaded 0. Now I have taken 0 here. 0 here. Okay. Now all of a sudden I called a delay program. Delay, a call delay, absolute delay program I have called. Here my delay program. Why we need to make delay? If I am not asked this delay, automatically in the fraction of seconds it will be going to change 0, 1, 2, 3, 4, 5 up to 255. It takes some fraction of seconds. Again it will be reached 255. Again it will be come back. We cannot observe the output. That is why we need to write a delay. After I am going to load 0 in the port 1, we need to wait for some time to generate 2. After 0, 1, 2, 3, 4, like that, so on. For each and every bit, we need to wait for some time. That is why we have write a delay program. How we wrote the delay program? See here, move port 1 comma A. Initially, port 1 will be 0, 0. I have called a delay, A call delay. Here in the delay program, delay. The automatically, if I am going to A call delay, the program will be coming over like this, like here. Move R4 comma hash 0 FFH means the maximum count will be 255. FF means it's a 255. I'm going to load 255 to R4. Again, move R5 comma FF 255. Again, I'm going to load with a R5. Move R6 comma 04 hash. I'm going to load with respect to R5 is 55. This is R4. This is R5. And this is 4 with respect to R6. This is not mandatory to take 4. If you want, you can take one more FF 255 so that the delay will be increased. Now again I have taken no operation, one more cycle I am going to include. Or else if you're not interested to use NOP operation, okay, you can use 05. Okay, other than NOP, here only you will get one count, extra count you will get. Or else if you want, you can take this as a 10, 15, no issues. Like that I have written. Then after NOP, now the signal, the program instruction will be coming here. Decrement jump if not equal to 0. R6, compare R6. If it is 0, go to next instruction, or else go to loop 1. No operation. Again decrement. Initially it will be R4. R6 is equal to 0, 4. If the instruction is coming over here, it will be going to compare with this decrement. It is not equal to 0, so that I am going to decrement this. Decrement to 0, 3. Again 0. Again loop 1. Again loop 1, no operation. Again DJNZ. Already if I am going to compare R6, decrement jump if not equal to 0. 3 is not equal to 0. So that again decrementing, going to loop 1. How many times? Here totally 4 times it will be going to rotate. 4 times with respect to this count. NOP to DJNZ R6 loop comma 1. Once it reaches 0, decrement jump if not equal to 0. If it is 0, it will be going for next instruction. If it is the satisfies, it will be equated to 0. It will be going for the next instruction. That is DJNZ R5 comma loop 2. Decrement jump if not equal to R5. R5 is FF means that is 255. It is not 0. Again loop 2. again move R6 comma R6 is 0, again no operation, again coming to here, loop 2. Like that, this will be 255 times it will be going to looping. Here we have a 4 times and here we have a 250 times. Again DJNZ R4, again it will be going to compare with this. Totally 255 plus 4. 255 plus 4. Totally these many times it will be going to looping. After that, return. After return means where it will be going after A call delay. In the last where we come after this instruction, A call delay. A call delay, it will be delay program. If I am going to return after next instruction of a delay, increment A. What is previous condition? Increment A will be 0 0. Now I am going to increment A is equal to 1. Initially A is equal to 0. Now A is equal to 1. Again S jump to back, short jump to back. Move A comma port 1. Now I am going to load port 1 is equal to 1. Initially 0. Now it is 1. Like that, again it will be taking A call delay. Again it will be coming 255 plus 255 plus 4 times. It will be keep on rotating. Again it will be going to moving back. Where it will be going back? Again it will be increment A. A will be next. A will be 2. Again S jump back. A will be 2. That will be going to loaded with a port 2. Port 2 will be 2. Like that, initially 0, then 1, 2, so on up to 255 means FF. It will be FF. It will be going to take FF. After that, it will be coming to 0 again. After FF, what is the value you will get? If you add FF to 1, you will get 1 followed by 0 0. 1 is stored with a carry flag. 1 will be stored with a carry flag. Again, it will be starts with a 0 0 0. Again, it will be keep on repeating the logic analyzer. We can observe this output. Got everyone? Got everyone?
Yes, sir.
Any
Yes, sir.
doubts? Any
No, sir.
doubts? See, 3 times they asked for 10 marks this program. Understand properly. See, once again I will explain. Here ORG00H, SJump 30H, ORG 30H that we know already. Move P1 comma 00. I am going to make a port 1 is a output port. Now I am going to clear the accumulator. A is equal to 00. Why? Because we are count will be from 00 to FFF. That is why initially we made it to 0. I have made it to A is equal to 0. Now I am going to load A is equal port 1 to be 0. Again I will take A call delay program I have written here. If you want you can make 2 more lines, that is move R2 comma hash FF, that is loop 1 loop 2 loop 3 loop 4 4 5 loops. If you want you can take how many loops you are taking, that much delay you are going to get. Okay, like that it will be going to count the values 255 4 times for one cycle. For 0, once it will be loaded to 0, it will take some time to run this program. Means we can observe the 0 here. If I am not writing this delay program, after all of a sudden 0 will be changed to 1 2 3, like that it will be reaches FF. Again it will be going to reach 0. We cannot identify the numbers. That is why here we can identify the numbers, that if I am going to load 0 with a port 1, 0 will be displayed for some times. It will be taking some delay program. After that it will be going to show port 1 will be loaded with a 1. Again it will be delay program. Okay, like that it will be keep on varying from 0 to FF. 0 0 to FF. Got everyone? Any doubts?
Yes, sir.
Doubt ಇದೆಯೇನ್ರಿ?
ಇಲ್ಲ sir.
Okay. Make a note of this program and write down this diagram. See, this is for up count from 0, 0 to FF. If you want to down count, FF to, see here, FF to 0, then again it will be reaches to FF, then it will be 0. You can use an instruction increment A replaced with a decrement A. Try this program, decrement program. After finishing this, try for decrement program. Kelsa idya?
Yes, sir.
See, when you are doing practical, you make a habit of writing program like this. The lines should be in the same. Everywhere you have to write the comments. Make the habit of writing the comments in the program. Okay, trace that program down counter. In the next class, we'll discuss about this one, BCD up counter and down counter. See, now you understood, I think, what is the necessity of delay in the program. The counters, we cannot observe the counting points. That is why we are going to make a delay program. You can easily observe that the pulses will be count from 0 to FF. ಅರ್ಥ ಆಯ್ತಾ? ಏನು ಅರ್ಥ ಆಯ್ತಾ? ನಿಮ್ಗೆ ಅರ್ಥ ಆದ್ರೆ ಸಾಕು ಸರ್, ನಮಗೆಲ್ಲ ಏನು ಬೇಕಾಗಿಲ್ಲ ಅಂತ ಹೇಳ್ತೀರಾ. Answer attendance, Abhashri.
Present, sir.
Adarsha.
Present, sir.
Adish.
Present, sir.
Ajit.
Present, sir.
Akanksha.
Present, sir.
Akshita.
Present, sir.
Amutavalli.
Present, sir.
Ananya.
Present, sir.
Anusha. Arif.
Present, sir.
Asha.
Present, sir.
Ashok.
Present, sir.
Smaran.
Present, sir.
Basuraj. Bharat.
Present, sir.
Srikari.
Present, sir.
Ashrita. ಚೈತನ್ಯ,
Present, sir.
ಸತೀಶ್ ನಾಯ್ಡು,
Present, sir.
ಶಿವನಾರಾಯಣಪ್ಪ,
Present, sir.
ರೋಹಿತ್ ಕಲ್ಯಾಣ್,
Present, sir.
ಚಂದನ್,
Present, sir.
ಅಹಲ್ಯ,
Present, sir.
ಚೇತನ್,
Present, sir.
ಚೇತನ್ ಎಸ್,
Present, sir.
ಚಿನ್ಮಯ್,
Present, sir.
ಜಿತೇಂದ್ರ,
Present, sir.
ದೀಕ್ಷಿತ್, ದೀಪಿಕಾ,
Present, sir.
ದೀಪ್ತಿ,
Present, sir.
ಧನುಶ್ರೀ,
Present, sir.
ಧನುಷ್,
Present, sir.
ವಿಘ್ನೇಶ್,
Present, sir.
ಕೃಷ್ಣ ರೋಹಿತ್,
Present, sir.
ಮನೀಶ್,
Present, sir.
ಮೇಘನಾ,
Present, sir.
ಗಿರಿಜಾ,
Present, sir.
ಗುರು ಕಿರಣ್,
Present, sir.
ಹಂಸ,
Present, sir.
ಹರ್ಷ,
Present, sir.
ಪ್ರತೀಕ್,
Present, sir.
ಜೇಸನ್ ವರ್ಗೀಸ್, ಜವೇರಿಯಾ,
Present, sir.
ಜಿತೇಶ್,
Present, sir.
ಕಲ್ಯಾಣ್, ವೆಂಕಟ ಸಾಯಿ ಪೃಥ್ವಿ,
Present, sir.
ಕಾಮಿರೆಡ್ಡಿ, ಪ್ರಸಾದ್ ರೆಡ್ಡಿ ಇಲ್ಲ, ಕಾವ್ಯ,
Present, sir.
ಕೀರ್ತನ,
Present, sir.
ಕುಬ್ರಾ,
Present, sir.
ಪೋನ ಉದಯ್ ಕುಮಾರ್ ರೆಡ್ಡಿ,
Present, sir.
ಶ್ರೀರಾಜ್,
Present, sir.
ಕುಶಾಲ,
Present, sir.
ಲಯನಾ,
Present, sir.
ಲಿಖಿತ್,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಎಂ ಚರಣ್,
Present, sir.
ಶಿವಕೃಷ್ಣ.
Present, sir.
ಹಲೋ ಹಲೋ
ಯಾರು?